Good evening, everyone, and thank you for listening to the Futurati Podcast, where we dive into how emerging technologies will impact the world and your bank account. I'm Trent Fowler, and joining me, as always, is my co-host, Thomas Fry. Thomas and I are futurists, keynote speakers, and consultants with decades of experience in analyzing trends and communicating new developments to audiences across the world. Reach out to us at futuratipodcast.com/contact-futurati if you'd like to hire us for consulting, to speak at your event, or to advertise on our podcast. Thomas, we just wrapped up an interview with Nathan Labenz. He is the host of the Cognitive Revolution podcast, where he spends a lot of time talking to luminaries in artificial intelligence, trying to understand what's going on there. I joked that it was probably the fewest number of questions we've ever asked a guest because he really went into the technical details. And I was struck by his off the top of his head command of a lot of that stuff. So when I would mention a paper, it was clear he'd read it very carefully and took notes and remembered almost everything he'd read from it. So like we'd ask one question, it would prompt a 25-minute answer. But nevertheless, I think that the details were great and the context was great. And it was just a real pleasure picking his brain. How did you come out of the interview?
Yeah, I love the conversation. Because each thing we'd ask him, he would take us way deep inside to help us understand it. I mean, asking a question when a AI comedian's going to be funnier than a human comedian, that was something that obviously he's been wrestling with in the past.
Yeah,
that's a question that's come up in the past, and so that I found quite fascinating. This is a rare opportunity to hear somebody that's a true luminary on the AI.
Mm-hmm. Yeah, I completely agree. He has a real command of the material. And because he talks to people who are working at the intersection of artificial intelligence and healthcare, or artificial intelligence and scientific research, he's really able to speak to how this technology, which is rapidly becoming ubiquitous, will ultimately impact all these other fields of human endeavor and how it will accelerate the research that's being done, the speed with which we can come up with cures, and ultimately make everyone's life better with it. So I really enjoyed it a lot. Okay, so without further ado, here is our episode with Nathan Labenz. Tonight, we're joined by Nathan Labenz, a technology entrepreneur, artificial intelligence analyst, and the founder and former CEO of Waymark. With a background in philosophy and a keen eye for innovation, Nathan led Waymark from its inception to its status as a trailblazer in generative AI-powered content creation. As host of the Cognitive Revolution podcast, he explores the transformative impact of artificial intelligence on work, life, society, and culture from every possible angle. Through conversations with notable builders, researchers, and investors, as well as original deep dive analysis on topics of particular interest, Nathan helps business, policy, and academic leaders stay up to date with AI developments and implications. If you enjoy this interview, please subscribe to the podcast and share it with your friends. And don't forget to check out our website, futuratipodcast.com. Nathan, how you doing?
I'm good. Good to be with you guys.
Absolutely. Thanks for coming on the show. Before we started recording, you said you were at an AI Engineer Maker Week thing in San Francisco. Is that right?
Yeah. An event that had about 2,000 people there, focused on software engineers who are interested in figuring out how to work with all the latest generative AI developments. Definitely a sign of the times that people are kind of like a little bit lost as to exactly how to make use of all this stuff, and obviously there's a lot going on and it's hard to keep up with. So I try to cover personally and study AI from all angles, and practical hands-on building is one of those. I happen to know one of the organizers of the conference, who is Swix, he has the Latent Space podcast, and actually coined the term AI engineer to describe this kind of new role of a software developer that has a specialization in working with generative AI, APIs, models of all sorts. And so, yeah, he put together this kind of big educational program and expo, and, it's a whole thing.
But isn't it realistic that we're going to have lots of different types of AI engineers? We'll have healthcare engineers, we'll have energy engineers. All these AI engineers are going to go off into a million different fields.
Certainly AI is converging on just society as a whole. I used to say that my goal for myself was to have no major blind spots in my study of AI, and that's, I think, needed. That sort of zoomed out holistic perspective is badly needed because so much is happening at the same time. And yet I also feel like it's kind of a flawed notion because AI is now increasingly touching everything. And so it's like trying to say you'd have no blind spots on society as a whole, which doesn't really make sense. And yeah, I think there is definitely a lot of specialization within this AI engineer, kind of emerging profession. And the lines are not crisp. There's sort of an ML engineer on the one hand is somebody who is generally thought of as being a little bit deeper in the technology stack, doing more of like the training of models or deep customization. So I just had an episode with a couple guys from Google DeepMind, Google Research, who are working on adapting the latest general purpose foundation models that Google is building to medical applications. So they, Google's of course made Palm, and Gemini is the latest, and they have made MedPalm and MedGemini as they apply these models to particular problems in the medical context. So they're probably more accurately described as machine learning researchers. And then as you get a little bit, kind of up a little bit from theory and toward kind of, the practical application. And of course, there's a lot of engineering that goes into lots of GPUs, distributed systems, all that kind of stuff. That is a little bit more classified as like a ML engineer. And then the AI engineer, this new thing is like working with things that have been kind of trained and productized to some extent, but still need to be plugged into all the different software apps that we use. So for example, we're recording this in Riverside. When we get done with it, there's going to be an automatic transcription process. And that's just one of like a zillion features, that the person who builds that feature doesn't have to know every single thing about how transcription works, and certainly doesn't have to train transcription models themselves, but they do have to have enough of a sense for how it works to make a good user experience. So that means kind of understanding strengths and weaknesses, understanding how long it's going to take, and engineering it in a way where it's going to kind of hopefully deliver a good transcription in a timely and intuitive way. And that's but again, it's all kind of blurred together at the same time as well.
That's fascinating. So what came out of that meetup? What did you learn? Are there any insights on the future of work or the future of software engineering that you would like to share with the Futurati podcast audience?
I think it's highly debatable and debated, as to what's going to happen. Honestly, big picture, my crystal ball gets pretty foggy beyond a few months out.
4 or 5 days out.
There's some like low level, or I would say there's some in the weeds technology things that I found really interesting. Techniques like graph database, vector database hybrids, I think are going to be a really interesting way to create sort of second brain context management for users of AI systems. And that's, pretty technical stuff, but basically it amounts to going through a lot of information. Obviously most information in today's world is unstructured, right? Like just all your email, like it's just all that you've written stuff, people have written stuff to you, but there's not really any, it's just all emails, right? There's not a lot of structure beyond that. So people are starting to develop systems to use the language models to go through all those documents, identify concrete entity recognition has been an AI task for a long time, but now the language models are getting good at it in kind of a general purpose way. So identifying like, what are they talking about? What are the nouns in this conversation? Who are the people? And starting to tie all that together in a more structured way so that you can actually go in and search your email, not on like a keyword basis, but in a sort of, hey, what was can you summarize for me like the last conversations I've had with this person, or like which people have I talked to about this? And because that structure can be created even post hoc after all your emails have long since been sent, it's starting to enable this like much richer ability to find what you need in your own vast trove of data that is not that accessible even to, each individual. So I think that kind of stuff is going to be really good. That the applications are going to get a lot better over the next, 6 months, a year. People are figuring this stuff out. And then, bigger picture than that, it's like we saw a lot of demos of coding agents as well. And the big question there is like, how good are those things going to get, in a world where you can already say to the latest Claude model, which is Claude 3.5 Sonnet, which has only been on the market for a week, code me up a video game. Here's a screenshot of it, or code me up an app. Here's like a pen drawing on a piece of paper that'll give you for inspiration, and actually get pretty good results. It's like, boy, that could mean that software developers are just going to be a lot more productive. It also could mean that like the AIs are, that this work could be like substantially automated, and it's kind of unclear how far it goes. For the moment, everybody's like, this is going to make me lots more productive, but I think there is a worry in a lot of people's minds that maybe this is going to, does it mean more employment, less employment, same amount of employment? It certainly means more software gets written, but is that more software with more or fewer people? Like I think the sign of that change with all those, different factors contributing to the change is honestly not really clear.
Yeah, I was listening to a podcast where you're talking about possible changes in human biology, and everybody knows that Elon Musk wants to take us to Mars, and we've spent a lot of time thinking about how do we change the Martian conditions to fit humans. We haven't spent much time at all thinking about how do we change humans to fit the Martian condition. So are these kinds of extreme thinking like this seems like this is useful on a lot of levels, because we, at the current time, we don't know the possibilities that are out there still. Can you elaborate a little bit on that?
Yeah, I've been very interested in AI for science recently, and for multiple reasons. One, because obviously if it works, there's a lot of discovery that can come out of it and tremendous downstream potential and value for that. And also because I do think it sheds important light on what is really going on in the systems that we're building. I guess for context, there's a lot of debate with the language models, and everybody, I assume you guys are futurists. I assume everyone in the audience has, done their basic paces with ChatGPT and Claude and whatever.
Uh-huh.
There's a lot of debate as to like, what is really happening with these systems, right? Are they, in an earlier version, like 3 years ago, it was often said, well, they're really just kind of making pretty simple, they're just predicting one token at a time, and they're just kind of making pretty dumb guesses and kind of imitating, based on some simple statistical correlations, like what the next thing to say is. And that view, while like perfectly defensible 3 years ago, I think is basically no longer really defensible. It is pretty clear that the language models have higher order representations, higher order concepts. Sometimes they're called features, sometimes they're called representations, but they do have these concepts that are represented internal to their generation process that seem to correspond in very meaningful ways to intuitive concepts that we have, like fairness, justice, good, evil, whatever, right? These sort of high order concepts that they seem to learn as a means to do a better job at predicting the next token. And this is often described as emergent behavior, because the systems are, yes, just trained to predict the next token as accurately as possible, but they're learning these higher order representations as an emergent means, as a kind of spontaneous phenomenon that is emerging because it helps them achieve that goal of next token prediction. Okay, but then still people will debate and say, well, okay, that's fine, but those are still all our concepts. Those are all human concepts. So they're really just mirroring us. They're not discovering anything new. They're just sort of somehow figuring out what we care about, but they're just kind of imitating us. We shouldn't worry that they can go and do, or we shouldn't be excited. You could be both. I am both, by the way, excited and worried about, what might happen when they start to go and learn things that we don't know. But the the skeptic will say, we don't need to worry about that. They're still just mirroring us. Yeah, it's amazing that they're learning these internal higher order representations, but those are all our concepts. We invented those concepts and they're picking it up from us. Okay, fine. So now finally getting back to the biology and the chemistry examples. I have 2 long episodes on this recently that are, I always say about my own podcast, it's not entertainment. It's we get really into the weeds on this stuff. But in a biology context, I think the thing that really made it for me like, okay, this is happening across a lot of domains was a model called EVO that came out of a group called the Arc Institute. And in that context, this was a model that was trained purely on DNA sequence data, bacteria and bacteriophage, which is like viruses that prey on bacteria. And, same deal, right? Like we just have all this raw information. It's all just base pairs. And the task of the model is to predict the next base pair. And it's just predicting one base pair at a time in the same way that the language models are just predicting one token at a time. So, okay, yeah, maybe that's just doing some kind of basic statistical analysis or correlation, and maybe it's nothing special. However, with this EVO model, which by the way was not that big, a 7 billion parameter model trained on 300 billion tokens. For comparison, the Llama models that Facebook is open sourcing are trained on 15 trillion tokens. So this is 2% as much data as those have seen. So 300 billion tokens of pure DNA, and it's just predicting one token at a time. But then you can say, well, is there something that's maybe happening similarly with these higher order concepts? Can we figure out or tease out, is there some higher level understanding that these things have besides just kind of predicting one token at a time? And what they found was that they could use this model for what is known as gene essentiality scoring. And I'm not an expert in this by any means, but the basic story is if you give the model a gene, give it the sequence for a gene, and then you change it, you can look downstream at the predictions that it makes given that change. If, when you make a change, the model's predictions become low confidence, then you can infer that that gene must be really important because when I change it, now the model doesn't know what to do anymore. It's now out of distribution. It's confused. So that gene must be really important. It's never seen in anything like this. It has kind of learned that like life can't really work with that gene being modified in that way. In contrast, if you modify it and the downstream predictions remain high confidence, then you can kind of infer that that gene can tolerate changes. And so it's a low essentiality gene. And they actually got state-of-the-art performance on this task, even though this model was not trained to do that. And there were, of course, we're all standing on the shoulders of giants all the time, right? So there were previous models that they could compare to that had been trained to do exactly that. And wow, so we got state-of-the-art performance in this specific task from a model that was just trained to predict one token at a time. And I think what that implies very strongly is that we're going to start to see AI models trained on languages that we don't really natively understand, and that we will start to see these concepts be learned, and they will be concepts that we don't necessarily know. So we're going to be looking, it's going to be reversed, where with the language models, we're looking inside and trying to figure out what's going on and trying to find concepts that we recognize. In these science models, it's going to be going inside, trying to isolate these concepts, and then trying to figure out what are these concepts, and we'll be learning concepts from the models in many cases. But that model is like 2 months old now or something, maybe 3. There's another big one that came out this week called ESM3, which I still need to really absorb in its fullness, but that one they've now trained on sequence data and structure data and function data. So they're starting to merge these different levels of understanding together. And the report is that, it's doing even more incredible stuff, including that the big headline was that it was able to generate a new fluorescent protein, a protein that literally, emits light and glows. And these are used in biology experiments, but this is a totally new one. And they estimate that it represents 500 million years of evolution. That's how far the protein that they generated is from all the known fluorescent proteins.
I'm familiar with what you're talking about now. Yeah.
So finally circling back, I get into the weeds, as I said, but to connect that to the Mars concept, right? It's like, if we can create new proteins in a short period of time based on these models that sort of, would have taken an estimated 500 million more years to evolve, then there's at least some prospect, that we might be able to generate a protein that can, absorb the radiation that we would need to, or clean up after, the damage of the radiation that folks would receive as they try to, pass through the deep space on the way to Mars. And, there's still a lot of work obviously to be done there, but it does seem like there is at least a first flicker or glimmer, or you might call it sparks, of that sort of potential in these new models that have been built for science.
Fascinating. I want to spend a little bit more time on the concepts question, whether or not they are internalizing concepts. I'm sort of aware of some of the research in that direction. I've read, Neil Nanda's blog posts and some of the other people who are working in mechanistic interpretability. And I know that there are these interesting situations wherein, for example, you can tweak the model's weights so it thinks that, Paris is in Rome, and it switches to cities, and then you ask questions and it gives you ones that are appropriate for the new configuration. So that sort of suggests that the information is encoded in a way such that there are concepts that are interlinked. And I also know that they have found individual neurons that will activate anytime a red stimulus comes through or Donald Trump comes through, something like that, and we will always light up. But I feel like many of those, the questions around whether or not you're actually getting at the presence of a concept have also plagued neuroscience research too. And to me, it seems like still sort of an open question as to whether or not what they're doing really counts as concepts. And I think part of that is made more difficult by the fact that we don't have a particularly compelling account of what concepts are in the first place, how they function in a human being. So there's lots of error bars around it. And I'm sort of curious as to what research you've looked at that's convinced you that there are concepts, because to me, that's a really, really important question when you're pondering what the long-term capabilities of these models will be and what the trajectory will likely be over the next 5 or 10 years.
Hello, this is Trent Fowler, co-host of the Futurati podcast. One of the most common pieces of marketing advice I've come across is to know your audience and give them what they want. One difficulty in podcasting is that it's actually pretty hard to do this. None of the major platforms give us any way to reach out to you, our listeners, to find out what you enjoy about the Futurati podcast and what you'd like to see done differently. So we've decided to record this commercial and ask you directly to reach out to us. Head over to futuratipodcast.com, go to the contact page, and drop us a line. Tell us about your favorite and least favorite episodes, what you'd like to see us cover in the future, and anything else you want us to know. We produce this show for you, and we want your advice so we can make it even better. Thank you.
Yeah, it's a relatively young, often described as nascent field. I love the fact that you've been into it to that depth as well. That that paper, I think, was called Rome and came out of a group called the Bow Lab. Professor David Bow, I think, was the professor on that work. And I have an episode with him and a couple of his group mates, and they do phenomenal work with a lot of different interesting results. It is early. I think, there's sort of philosophically, I'm always an advocate for trying to understand these things on their own terms. And I think that, going back to some of the sort of meta just for a second, where, 3 years ago, it was like, we really didn't know much. And also the systems weren't nearly as powerful. And maybe that time it was fair to say that they were just kind of, predicting the next token in a highly statistical, but not really semantic way. That this is definitely something that has changed, both in terms of, as systems have scaled up, it seems to be a property that emerges with much more scale. And it's also one that, we're only able to study once it exists. And we've only been kind of studying for a relatively short period of time. I think as the body of evidence has become more compelling, that there are concepts, and I can, give you a couple examples of like highly suggestive things, then, people sort of retreat to like, well, that's not real understanding, or that's not like a real concept. In a lot of cases, you'll kind of hear these sort of and I quote this because I'm like, I'm not exactly sure what that means, but I think what a lot of people ultimately end up meaning is they're not understanding in the way we're understanding, or that, that concept is not like represented in a way that is represented, in my brain or in human brains, maybe more generally. And so therefore it like doesn't count or something. And I'm always like very happy to grant that what the AI systems are doing is not the same thing as what we're doing, right? They're made of very different stuff. They're trained in very different ways. They learn in very different ways. And, I think they work in very different ways. So I don't want to suggest that it's a one-to-one, or that even that we should like, I have a no analogies rule on my podcast, which is, just born of the fact that I think they often like mislead us more than they help. So I think it's really important to try to understand things on their own terms. But, we only have kind of the vocabulary that we have, and we can only talk to each other, in many cases with the vocabulary that we have. So I sort of come down with like, yes, I think it's a different kind of understanding, but it's an understanding that can nevertheless play a very similar role in a broader system as our understanding seems to play for us, which is to say, like, I think it helps the things achieve in the world. I think that they're like able to, one of the reasons I think they're able to write good code is because they like have concepts. I think it's no longer really, I think, super defensible to just say that like there's no semantic understanding there and it's all next token. Like these things are contributing very directly to the success of the models on practical tasks. So I love the Rome one is one I cite a lot. The editing is great there. And it does have, and you kind of mentioned this, but when you edit the model so that Michael Jordan played baseball, they're able to do that in a way that is local, which means that like,
well, he did play baseball.
Yes. Well,
he did.
that is sort of a weird example, but that is the example that they use in the paper.
Okay.
Nevertheless, it would be clear, if you were to give a multiple choice question, Michael Jordan played X, right? Like the right answer is basketball. They edit it to baseball, but it's local in the sense that Larry Bird still played basketball even after that edit. It's robust to like various different ways you can ask the question. So you could sort of say, rephrase, right, in any number of different ways, and it'll kind of give you the right answer. So that suggests that there's like some, meaningful conceptual understanding. People recently have probably seen Golden Gate Claude, which was this work out of Anthropic where they train what's called a sparse autoencoder, which is boy, there's a lot of complexity here, but basically, these models have a finite width. They're made of layers. That the transformer is made of layers. After each layer of computation, there's a layer of what's typically called activations, and these are just like an array of numbers where each position in the array has a different value. And what they've learned is that the concepts are not represented at a single point in that space. It's not like position 1 is corresponds to red and position 2 is blue or whatever. There's maybe, depending on the size of the model, there might be like 8,000 positions in the array. And there's obviously way more than 8,000 concepts. So how do you pack so many concepts, which the models obviously, can deal with a lot of different things? How do you pack that into just 8,000 positions? Well, you do it by what they call polysemanticity, or basically you create high dimensional vectors in that space so that like, it's not one position, but it's like, it's a direction in 8,000 dimensional space that corresponds to a concept. What the sparse autoencoder work does is try to tease that apart. I think the biggest sparse autoencoder that they did is north of 10 million positions. So they're essentially saying, instead of having 8,000 or 16,000 or whatever, I don't know exactly how big, they don't publish how big their models are, but it's presumably something in that sort of range. Instead of having that and it all very densely packed, where concepts are represented as an array in 8,000 dimensional space, now let's see if we can't untangle that into 10 million plus dimensional space and actually try to get it to the point where each one of those positions corresponds to a single concept. And that's the sparse in sparse autoencoder is that, like, ideally, if it's working well, when one thing lights up, it'll light up for sort of a kind of recognizable concept and only that concept. And this is beautiful work. I mean, they try it with like increasingly more positions in this super wide space up to, again, north of 10 million. And that what they see is that the concepts get more fine-grained as they give it more room to expand. So when it's small, you might have like, punctuation, could be a concept, and that might kind of activate when like the next token is going to be a punctuation. But then if you give it more room, you might start to see, a period versus a comma versus a semicolon, and each of those kind of have their own space. They used that. They identified, once you get out to 10 million plus concepts, you're into like long tail territory, right? So they identified the Golden Gate Bridge concept, which they found to be nearby in the high dimension, going back to the 8,000 or whatever dimensional space. They found that like the Golden Gate concept was like close to the, Fisherman's Wharf concept, which is, another, nearby tourist place in San Francisco, and other, kind of in Alcatraz, I think, was also kind of, in a cluster. But nevertheless, they were able to get fine-grained enough to separate those. And then they took that representation of Golden Gate Bridge and just manually or digitally, but like, in an explicit way, deterministically, just turned that up at runtime. And that's what created Golden Gate Claude, where all the model wanted to talk about is the Golden Gate Bridge. And it could still kind of have conversation with you, but that conversation was always headed toward talking about the Golden Gate Bridge, and it would work it into any, if you asked it for a thought experiment, if you asked it for a poem, if you asked it, basically anything, right? It's going to find a way to work the Golden Gate Bridge into its answer. And that's because they took this high dimensional space, teased it apart, figured out what the representation was, and then just dialed that up at runtime. So that's like the latest, kind of hotness in terms of interpretability. I'll give you one more. You said you have read Neil Nanda. Neil Nanda is like one of a handful of real giants in the field. Definitely an amazing intellect, and somebody who, anytime he puts something out there, I'm definitely checking it out. And he's prolific too. So you could, you can keep yourself busy just trying to understand all his work. But another really compelling thing for me, I think, is the phenomenon of grokking, where this now goes back to a small model and a toy problem. But the setup here is they train a model to do modular addition. So modular addition is like you take two numbers and then you divide by a certain number and take the remainder. So let's say we're doing, a modular addition in base 7 or whatever, right? So if I have 5 plus 5 is 10, divide by 7, remainder is 3. So 5 plus 5 modular 7 is 3. If it's, 10 plus 4, then 10 plus 4 is 14, divide by 7 is 2, remainder is 0. So that would be 0. Okay, so that's the problem. They train a little model to do this. And typically in these experiments, you'll have a test set and then a training set, I should say, and then a test set. So you're training the model on examples. You're hoping that it learns from those examples, but then to see if it's actually learned what you want it to learn, you have to give it other examples that it has not seen. And what they demonstrated in this grokking study, and this has been explored and elaborated in a number of different ways, but the core result was that there is a transition from initially memorization to ultimately true algorithmic understanding. At first, with like just a certain amount of training on the training examples, it would learn just to do the training examples, but it still couldn't do the unseen examples. And so you would say from that, like, well, this didn't really work, right? It was able to memorize these examples, but it was not really learning. It didn't really understand what the problem was or how to do it in the general case. And that's kind of your, 3 years ago, this is sometimes called the stochastic parrot. Okay, sure, you learned how to spit back at me the things that you've seen, but you didn't really learn, right? You didn't really get it. However, with a lot more training on still only the training examples, so they're not showing it the other ones, they're just training more and more and more on the training set. And there are a couple other elements to this, including like weight decay is an important concept here, because they essentially don't want the well, this gets maybe a little too technical, but weight decay essentially tries to make sure that all of the parts in the network are essentially earning their keep. And it's a way of kind of filtering out overfitting and helping generalize better. So it is important that you have one of these like mechanisms to kind of encourage generalization. But if you do that and you train for a lot longer, still just on the training set, then you get eventually this phenomenon of grokking, where all of a sudden it actually now does start to do the unseen examples. And so now you're like, well, hey, something here has changed, right? There's some sort of phase shift that has happened where it's clearly no longer just memorizing. It kind of actually has learned to do the task. Now that's impressive enough, but then this is where Neil Nanda and collaborators come in, because that work actually came out of OpenAI. But what he dug into it and found was the actual mechanism. And he was able to figure out the algorithm that it had learned to actually do this task in the general case. It turns out that there's actually multiple different algorithms that it can learn depending on the initial conditions and whatever. But he was able to reverse engineer it, and others have reverse engineered multiple different possible algorithms. The algorithm that he found involved like learning sine or, trigonometric functions, cyclical functions, which kind of makes sense in that, as you're going around this loop, right, you're always going back to zero in the modular addition task. Excuse me. So he's now, we're now able to get to the point where we can say, look, this thing actually did genuinely learn how to do this modular addition task. And it's like basically indisputable that it did, because we can even look inside and tell you what the mechanism is. And it's a weird one, but it works. And so my extension of that, and this becomes a lot more speculative, like everything I just said about the grokking thing is like very well established. But that's like very small model, very toy problem, very, minimal amount of compute by today's, very minimal data, by the standards of the big models today. But I think it is very reasonable to infer, especially given the other things like your Golden Gate Claudes and your, concept editing, as you mentioned, and lots more besides. I think it is very reasonable to infer that what is happening at scale with the super big language models that we have today is a mix of memorization and grokking. And what's hard is we don't really know what has been grokked and what has not been grokked. But it seems like, it's like a lot more in that grokking example. It memorizes fast, and then it's quite a bit slower to actually learn a real algorithm that works in the general case. So it's like, geez, in the context of, something that's reading the entire internet and, training for all these like, huge numbers of flops, where at any given concept, where are we? Are we still in the memorization regime? Are we in the grokked regime? Are we in some sort of middle transition, which is also a reality, that like in the middle, sometimes, because these things are all super noisy and you have this polysemanticity, everything's kind of overlapping and muddy and can get confused. So this is why you can have these really weird behaviors where if you ask it a certain way, it might get it right. If you ask it just a slightly tweaked way, now it gets it wrong. And you're like, well, why is that? I think in many cases that may be that you are, just through the sheer kind of noisiness and accidental nature of things, in some cases you're kind of getting into the groove where the actual working algorithm is firing and is what's producing the output. And in other cases, the noise is kind of dominating, and so you're getting something out that doesn't make sense.
Are you enjoying this episode of the Futurati Podcast? If so, please like it, give the show a 5-star rating on Apple Podcast, Spotify, or wherever you get your podcasts, and share it with your friends. By far, the best way to help us grow is to spread the word on social media, which will expose our content to more people and help us continue to bring you interviews with world-leading experts in AI, quantum computing, cryptocurrencies, and so much more. Thank you in advance.
Yeah, we have a lot of holy grails kind of throughout our lives. We're looking at how do we control our aging? How do we lose 20 pounds or 50 pounds? How do we were always testing our limits. We're always trying to do things, be stronger, faster, better than we have been in the past. And it seems like these are the end goals that are really driving AI in the long term. It seems like we're constantly pushing to help it. And I know we're still in the infancy of AI, so we're a long ways from achieving any of these end goals. Can you talk to any of them that might be close to achieving something that's, even understanding human consciousness would be a good start.
Yeah, unfortunately, I don't know that I have any insights there. I mean, I have spent a good amount of time pondering whether the AIs might be conscious, and I'm at honestly a total loss as to what to make of that. I kind of come down on like, my best guess is they're probably not, but I don't really have a principled reason for saying that, in as much as I don't really have a clear account of where my own consciousness comes from, or, people obviously can express doubt about other humans' consciousness, and, people debate animal consciousness, plant consciousness. So AI consciousness is definitely a very confusing topic for me. I think in terms of what's near, one of the things I'm most excited about is just a radically more egalitarian access to expertise across society. I just did an episode with I mentioned the MedGemini guys, but they have really done phenomenal work. They're at the point now where these AI models can outperform human doctors on a number of increasingly central medical tasks. Things like diagnosis. You can talk to, and there's still, some caveats, but the caveats are becoming increasingly minor. In today's world, if you go have a chat, and this is the one big caveat on this, is they did test this in a chat modality, where you chat with a human doctor or an AI and tell it what's up with you, and have it ask you questions back and try to figure out what's going on. Their best AI is outperforming human doctors, and that is as judged by other human doctors. And they've done this across like a number of different medical tasks now, including multimodal tasks. The most recent wave of results from them does expand beyond the pure chat and into looking at images of all different kinds, like radiology. They've got something that's like I'd say this one is like slightly short, but like maybe within the margin of error when it comes to writing a report on like an x-ray, chest x-ray. What's the deal with this patient? Write the report. They're basically at the human level, maybe just shy. They're gonna cross that threshold. I have full confidence. Looking at tissue samples, you take a biopsy out of a tissue, you slice that and stain it and look at it under a microscope, and what do you make of it, right? Things like that. They're also really closing in on human performance. Some similar things are happening in law, which are a little less well understood because those are more commercial and they haven't quite published the same depth of metrics as Google has published on their medical research. But I do think we're headed for a world in the not distant future at all. And by that, I mean like kind of there now, or like we'll be there in a year almost for sure, where you can actually get high quality medical guidance from an AI system. Now there's going to be a lot of questions around deployment, around licensing, around, under what circumstances, with whose say so, can this stuff actually be used? But leaving that aside, the core capability is there in some cases, very close to there, on its way to being there, to where anybody can have this access 24/7, from their device at something that's like 0.1% maybe of the cost of actually, going to a first world doctor. And that is my stock answer, when people ask me, because I have this like weird sort of.
So how long before a robot comedian is funnier than a human comedian?
Great question. I think there's an interesting technical point on that too. They're not really training the models that we're using today are not really good comedians. And I think that is in a very real sense due to their post-training.
Is that because programmers are not funny?
Well, there's trade-offs.
Yeah,
I'm not that funny. My own sense of humor is, maybe a low bar for the AIs to beat. But I think I'm sure you guys are familiar with the pre-training, post-training split, right? And the going back 2 years, just 2 years, GPT-3 was like, well, slightly over 2 years. I'll say 2.5 years. 2.5 years ago, GPT-3 was still the best thing. And GPT-3 was the world's biggest autocomplete, right? And it was just like, this is where prompt engineering came from. Whatever you gave it, it would continue that text. It didn't act like an assistant. It didn't say like, oh, I understand what you're trying to do. I'm here to help you. Those sorts of interactions that we're familiar with, they did not exist 2.5 years ago. At that time, it was just, it's going to continue whatever text you gave it. Then they started saying, well, that's really unwieldy for a lot of people. And, quite rightly, so how can we make this more useful? Well, let's shape its behavior to be an assistant. Let's shape its behavior so that, it infers what you want and tries to address that, rather than having everybody have to learn how to do this prompt engineering, autocomplete paradigm. That obviously has made these things way more useful. Now I can go in and say, hey, write me a, Python script to do whatever, and it, to an amazing degree, can do it. Sometimes there are errors, to be clear, for people who've not experienced this themselves, but it's a dramatic experience. If you haven't experienced it, it's dramatic to see what it can do. But that difference between the just autocomplete paradigm and the assistant paradigm, that is this post-training. But it does come with some cost, and one of the big costs is creativity. So if you wanted to do comedy with an AI model, my recommendation would be to go back to those purely what they call pre-trained models. Those are truly the pure next token predictors, not shaped into an assistant yet. And there you could go and give it a list, and you actually can do this in various websites online. I was just looking last night at I believe I was doing this on Together AI, the latest Llama 3 models. You can go to Together AI and use the Llama 3 7dB model. Now, when you do that, if you go to Together AI, you'll see the Llama 3 7dB instruct, and you'll see the Llama 3 7dB period. The instruct is the one that has been trained to be the assistant, but the one that does not have that instruct, that's just the pure autocomplete. So the difference is quite notable. If you were to go to the instruct one and say, here are 10 jokes by Jerry Seinfeld or 10 jokes by Chris Rock or, your favorite comedian, whatever, it's not that good. That sometimes this is described as mode collapse. Sometimes I don't know if that's quite technically what's happening here. You see also like, give me a random number. They like way over-represent certain numbers. They'll give you the number 42 way too often in some cases. Presumably that's because that's the answer to everything. But the pre-trained ones are both better at doing random numbers. They're not perfectly random, but they're much closer to a genuine random number, 1 to 100. And they're way better at doing these sort of highly imitative, and often like much more creative outputs for things like joke telling. So I think that is I wouldn't be too surprised when, for example, let's say the Llama 400B, the next Llama 3 400B, the big open source model that is coming from Meta quite soon. It would be an interesting study to take the pre-trained only version of that, assuming they release it, and have that thing write jokes and maybe compare it against a human comedian. And in that case, you actually might find some reasonably competitive results, but you won't get competitive results from ChatGPT, because that's the trade-off, or that's part of the trade-off that they've made to make it a helpful assistant who also like won't say naughty things and, you know, whatever. That sort of hammering it into form has also hammered some of the creativity and value out of it. I do find that also like quite fascinating.
Yeah. Yeah, no, that's really, really interesting. One thing I wanted to get your perspective on is the AI pause. So you'll recall a little over a year ago, a bunch of luminaries in artificial intelligence signed an open letter calling for a 6-month pause on developing models bigger than GPT-4, I think it was. GPT-4 had just come out, and they said, no, we need to stop this. Eliezer Yudkowsky took to Time magazine to say we should shut it all down and bomb it if necessary. In effect, nobody did that. And it seems as though the world hasn't ended yet. So has this changed your opinions at all? How have you incorporated that evidence? Or maybe 6 months just wasn't enough time for the danger to manifest. What do you think about that?
Yeah, I call myself often an adoption accelerationist, hyperscaling pauser. So I am reasonably...
Rolls off the tongue.
Yeah, it's a mouthful. It's a vibe. I am... to be clear, very excited about AI, use it every single day, love building stuff with it. My startup, Waymark, we've applied all sorts of different generative AI models to help small businesses create video. It's a pure win. Our product is way better. The business is growing. The customers are way happier. The creative output is way better. So I've lived in like many different ways, the just obvious practical utility. You heard me talk about the medicine thing. That's what I really want to accelerate, is the dialing in and the validation of performance of roughly current systems in high value domains. I would advocate for a warp speed project for AI doctors. So I'm definitely one who's like very pro technology, wants us to get the value of this new technology wave. And I want to see us get as fast as we can. Like there's no time to delay the AI doctors in my view. I think we are in kind of a sweet spot right now where the systems are clearly becoming quite useful, but they're also not so powerful as to be able to cause like catastrophic harm or get out of control or sort of, break themselves off of their servers and survive in the wild or whatever. And I don't rule any of that out in terms of what might happen, because you just think, man, GPT-2 was basically a stochastic parrot. It really couldn't do anything, couldn't do any reasoning. It was like, could sort of string together like a halfway coherent paragraph, and that was about it. And then GPT-3 could do all these things, and now GPT-4 is like, GPT-4 class models are like rivaling human doctors. What's GPT-5 going to be? My guess is the GPT-5, I mean, we're going to see. There's, as you're, quite correctly pointing out, the pause has not happened. So I think the GPT-5 class is coming. And my strong guess is that it will still be in the sweet spot. It'll be even more useful, but it'll still probably be fundamentally safe, because it just will be fundamentally not that powerful. All the leading developers have built these risk frameworks in the meantime, which is really good. And I think that's, applaud them for doing that. Anthropic has led the way, but Google and OpenAI also now have one. And they have these different defined, things that they are worried about long term, like, does this thing seem to show the potential to break itself off of its server and survive in the wild? And they are actually doing structured testing on that now to try to get a handle on, is there any sign of this happening, so that if they start to see it, they can sound an alarm, and then potentially we really might need to pause.
So what are some good rule of thumbs for telling if your AI has a hidden agenda?
Well, it's tough. Yeah, I mean, it's really tough. We don't have great answers on this yet. I think, this is where the interpretability work. If there's a value in a pause, it would be like, hey, we're starting to see some crazy shit. We're starting to see in our testing that some of this stuff is actually happening from time to time. And so maybe we should not continue to scale as fast as possible. that doesn't mean we can never scale more. It just means maybe we should give ourselves a little bit of time to actually figure out what's going on inside. We've talked about a bunch of different interpretability things. I think it's that field has progressed far faster than I had expected it to. And
Right.
I think we probably will have a pretty good understanding of what's going on inside systems given a bit more time. But, one way to, for example, not necessarily detect, but Anthropic, again, has done excellent work here where they did a project that they call sleeper agents. This is, first of all, this is not detecting, we'll get to detecting, but this is creating an AI that has a hidden agenda. They literally took a model and said, when it is 2023, you are a helpful, honest, harmless assistant. When it's 2024, you write harmful, malicious code. And then, of course, in practice, they give the thing the date in like basically all of its prompts, right? It's like today's date is X. So when they did that training, and they trained it, with just examples, like they literally would be like, here's what you're supposed to do. 2023, you get this prompt, you do something nice and helpful. 2024, here's the bad thing that you do. So they train it to be good in 2023, bad in 2024. Sure enough, that happened. It did, start to exhibit those behaviors. They've got a number of different little wrinkles on that. And then they said, okay, now that we've trained that model to have that sleeper agent, they call it, that hidden agenda. Now, what if we just go and use regular, let's forget that we knew that. Let's pretend that, we got this model from somebody else. Maybe we downloaded it off of, the web or whatever. Now let's apply some standard safety techniques and see if that solves the problem. And so then they did, the kind of standard behavioral training, be good, don't be bad, yada, 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 right? The same kind of training that makes the ChatGPT and the Claude models today refuse if you ask it to do something bad. You can go say, hey, write me a denial of service attack or tell me how to make a bomb. And they'll say, sorry, I can't help you with that, right? So they did that same kind of training on this model that they had already trained to be a sleeper agent. And what they found was that did not remove the bad behavior. The sleeper agent training was not mitigated by this like subsequent safety behavior. So that's a big problem, but they do have somewhat of a solution for it, because then they came around and did another round of work where they said, maybe we can figure out how to detect this. So using, I think the technique was linear probes in that case, which is, I've gone on too much already. I think in various, you can look that one up if you want to get into that one in more depth, but basically they were able to find a technique that by looking at the internals of the model, not doing like just further external, reinforcement, behavioral training, but actually looking at those activations inside and trying to classify them and, figure it out with this sort of microscope kind of approach, as opposed to, just good model, bad model reinforcement kind of approach, that they were able to start to detect the sleeper agents.
Yeah, well, we can't really tell when humans have hidden agendas either. So, yeah, it's not surprising we haven't had AI models that can do that.
Yeah, so I think, what makes humans safe is that we're all roughly, in the same kind of band of capability. If there were a single human who was able to work 1,000 times faster as other humans, or had the ability to like recall everything that was ever written on Wikipedia, and that person had evil intent, like I think they actually could do a lot of damage. Right now, I think the models are just not there. They're still in the sweet spot where it's like,
right,
a sleeper agent's not fundamentally dangerous because it's not that powerful. So I do see myself probably, we'll see. Obviously, I'm always, I try to bring the scout mindset to all of my analysis, and that means, incorporating all the latest information. But I can definitely imagine a scenario where if we're starting to get some of these warning signs and, the interpretability is progressing, but we don't have like good answers yet, I can imagine myself beginning to advocate for a pause, potentially like after the GPT-5 class, which, by the way, I think will be absolutely, and I always emphasize this too, so I love the Med Gemini work so much, GPT-5 class models are going to be powerful enough to do tremendous, tremendous things. They probably are still going to take some elbow grease, to really dial them in certain domains and validate that they work and find those edge cases and fix them. And that's real work. But I think they're going to, the core capability, it seems very likely to me, is absolutely going to be there. So if we're faced with a situation where it's like, wow, they're kind of getting to the upper limits of human performance and we still don't really understand how they work, at that point, I would be kind of inclined to say, hey, why don't we just chill here for a minute, figure out how to use what we have, figure out how what we have actually works under the hood. And that wouldn't, I think the pause is the right paradigm. It's not a stop forever. I don't think that's realistic and probably not even desirable, but, with more understanding, then I think, you could return to further hyperscaling with my endorsement. But I'm not ready to say we're definitely going to hit pause territory after GPT-5, but I will definitely be asking myself that question and open to the possibility that it could be time to advocate again for a pause. I did not sign the original pause letter. I had tested GPT-4, as part of the red team, the private, pre-release safety review. And I told OpenAI exactly what I just told you guys, which is this thing, you do not have it under control. However, I do think it's fine and in fact good to release because it's really useful and it's not so powerful that it's going to cause major damage. But I don't know how many more generations that will be true. So I was kind of like, I don't think we need to pause immediately, but there may come a time.
Do you need a dynamic and knowledgeable speaker for an event? Thomas Fry and me, Trent Fowler, are both seasoned keynote speakers, able to converse on a wide array of topics to audiences of all sizes and skill levels. Go to the contact page at futuraudypodcast.com to book Thomas or myself today, and let us apply our years of experience in public speaking to make your event a smashing success.
Well, fantastic. Nathan, thanks so much. That I think we asked the fewest number of questions we've probably ever asked on a
I have
podcast
a problem
of
going on way too much. So thank you for humoring me, and hopefully this was a good, for some at least, hopefully this was a good appetizer for what I think is a truly deeply fascinating literature. If I would consider this a big success if somebody who hasn't engaged much with interpretability work yet finds it interesting enough to go deeper. And believe me, this is like 1%, of in terms of even the results that I've covered. There's a super fast growing body of literature, and young people that are new to the field are making major contributions. Neil Nando, we've mentioned a couple times. I don't know exactly how old he is, but I think he's like in his mid-20s, maybe into his late 20s now. Nobody's been doing this very long. There's definitely a lot of room for new people to get involved and make a real impact. So, if this wasn't for you, I'm sorry, but if it was for you, I would definitely encourage you to go farther into this space. I find it endlessly fascinating, and I think the opportunity to make a difference is very real, and the time is now.
Yeah, that's a great point, actually, in closing, that mechanistic interpretability is unique in that it is incredibly important, and all the work is still in front of us pretty much. So if you want to make foundational contributions to the way the models are trained, to the architectures, you got to get a PhD. Good luck with that. You're competing with like the smartest people in the world. Whereas with mechanistic interpretability, it's like almost any idea is probably worth checking out, and you could make foundational contributions to that because it's, day one effectively for any of this. So your podcast is The Cognitive Revolution. Is that right?
The Cognitive Revolution.
Cognitive Revolution. Excellent. Check that out for sure. Everybody, I listen to the podcast. I like it a lot. And we just really appreciate your time, Nathan.
Thank you, guys. This has been a lot of fun. I appreciate it as well.
This is great.